Welcome once again to today's physics class. In today's class, we are going to be solving question number 3 on this principle of moment. Now look at this question here. It says a 3-meter uniform plank of weight 60 Newton rests on 2 supports at its ends. A man of weight 60, okay, that is 600 Newton, stands 1 meter from one end. Calculate the reaction at the other end. So let us first of all get the diagram. Now look at what we are going to do now. We draw the diagram. Since we are told that what the meter, okay, the plank is 3 meters supported at its ends. So then we are going to have a reaction here. We can call this one R2. So this side here is R1. Now we are told that the weight of this body, remember this is 3 meters for the length. The weight of the body is 60. And remember, the weight of the body we act at the center, which is for 1.5. Okay, so that is where the weight we act. That is for 60 Newton. Now, we are told that the man stands 1 meter from one end. We don't know, we can place it here, we can place it here. But let's place it here. Since 1 meter from here, let's place the 600 Newton there. Then the distance where the man is standing is from here to here, okay? Remember I told you when solving moments, you must always consider every distance to the line of action of each force. Now the distance is what? 1 meter. Okay. Now the weight of the body is acting from this point, from this here down to this point. So, which means here to here is what? 1.5 meters. So that is what is happening here. Now, we are going to be applying the principle of moment. The first principle of moment we are going to apply now, we have the sum of the upward forces, R2 plus R1 is sum up to be equal to this, which means R1 plus R2 is equal to what? 600 plus 60, which is R1 plus R2 equal to 600 and what? 60 Newton. Now, let us get something here. From here, we are going to take moment about any of the points. If we take moment from here, let's take moment about this point. So if we take a moment about this point here, it means the body is turning this way, okay? Which means we have a total moment. So this point here, this force here, this one will be 0. Why? Because we are taking moment. That is the turning point. So this one now will give us the what? The anti-clockwise. R2 here is the anti-clockwise what? Moment. Then why these two? They are turning this way. They are turning this way. They are the clockwise. So which means clockwise moment equal to what? Anti-clockwise. From here, we now have the distance from here to this point here is 3. So that is where the line of action. So this distance is perpendicular to the line of action of this reaction. So which means for the anti-clockwise, we have R2 multiplying this 3, R2 times 3 equal to, that is the only moment we have there as an anti-clockwise. We have R2 times 3 equal to, where is this one acting? The perpendicular distance here is 1. That is 600 times 1 plus, yes, 60 is at this point, which is 1.5 meter. To give us 60 times 1.5. Now let us multiply. So R3 now will give us equal to 600 plus 60 times 1.5. Let's go. R2 now equal to 600 plus, then 60 times 1.5 will give us 90. So R2, okay, everything over what? 3, because R2 here is multiplying 3. So R2 now becomes 690 all over 3. That is 3 here, 3. The answer now becomes R2 equal to 230 Newton. So that is the reaction at the other support. But let us also get reaction 1 at the same time. So R1 plus, remember that R2 is now 230. 230 equal to 660. So let us get R1. So R1 is equal to 660 minus 230. Let us subtract. So taking this one away, R1 is equal to 430 Newton. So remember, if you add the two of them together, they must give you the same value, which is 660. So that is what will make the body to be in what? Equilibrium. So this is the answer. This is how far we can go. If today is your first time of coming across this video, help us to share, like this video, comment, follow, so that you will enjoy most of my lessons. Bye.